Last video for this lesson set. So this is module 4, lesson 11, and we are looking at the last video 4. You don't need to watch this lesson unless you're having a hard time with those mandatory practice problems or those must-do practice problems. So this is a similar sort of scenario, and I'm going to work myself through it in writing an equation, finding some example situations for this given problem, and then answering sort of X and Y intercept questions. Students in Eric's gym class cover a distance of 1,600 meters by running or walking. Most students, including Eric, do a bit of both. Okay, so he's going to run and walk in there. Eric can run an average of 200 meters per minute and walk an average of 80 meters a minute. So we need to create an equation for this. We need to then look at finding some combinations that fit for this situation. So we're going to just find essentially a table of values. And then after that, we are going to figure out what if he only ran, which would give us one intercept, and what if he only walked, which would give us another intercept. So let's first create our equation. So the numbers that we need to pay attention to are this 1,600, that's our total distance that we're going to travel. Then we have this 200 meters per minute and this 80 meters per minute for running versus walking. So looking at these meters per minute, this sort of label here should indicate to you that this number is going to be a coefficient. And it doesn't matter if it's going to be attached to the X or the Y, it's just going to be a coefficient. I say that because we have meters per minute, where the X or the Y that we put in there are going to be the minutes that we would see him running or walking. So we are going to say this 200. Let's actually use even different different values instead of saying X or Y. We'll actually say R versus W. 200R plus 80W, essentially where R is the number of minutes run and W is the number of minutes walked. And that all needs to equal up to a total distance of 1,600 meters. So if he ran for 1 minute, then how much would he have to walk? If he ran for 10 minutes, how much would he have to walk is essentially what we're going to be asking here. Okay, so let's find some example situations or example solutions. Let's start out with running for a minute. Okay, we'll take it really slowly and easily. If he ran for 1 minute, that means he ran for 200 meters. And that means he has, let's see, 80, that's 200 meters plus 80W is equal to 1,600. So that means we're going to subtract 200, subtract 200. That means 80W is equal to 1,400. I already don't like that. Why? Because 1,400, I want to think of it as if it was 14. 14 doesn't divide by 8 very nicely. Excuse me just now. I just burped a little bit. All right, but either way, if I say 1,400 divided by 80, I get 17 and a half minutes of walking. So one combination that we could say is he could run for 1 minute, run, well, I'll just make my combinations here. So run for 1 minute, walks for 17 and a half minutes. Okay, let's do another one. What if he runs for 5 minutes, right? 200 times a 5-minute run is equal to 80 times W equals 1,600. What is that going to get me? So 200 times 5 is 1,000 plus 80W is equal to 1,600. That means I have 80W is equal to 600. 600 divided by 80 is, wow, I just did that wrong. 600 divided by 80 is 7.5. Okay, so run for 5 minutes, walk for 7.5 minutes. And then let's do one last one. FYI, 1,600 meters is about a mile. So just to put that in perspective, would it make sense for him to spend about 18 minutes if he ran just a little bit and then had to walk the rest of it, yeah, it would probably take around 18, 19 minutes. If he ran for 5 minutes, and then he would just need to, if he ran for 5 minutes and covered a little bit more than halfway, last half or whatever, or a little less than, takes 7.5 minutes. Last one, let's do an even number for running and see what happens there. So I'm going to say, what if he ran for, let's say, 4 minutes plus 80W is equal to 1600. So that gets me 800 here plus 80W is equals 1600. I'm going to subtract 800 on both sides, so I get 80W is equal to 800. That means he would be walking for 10 minutes. So if he ran for 4 minutes, he would have to walk for 10 minutes. Yeah, table of values, that's all we created. Last but not least, we are going to take this equation. What if he only ran? What if he only walked? So we're going to do that hiding of sides like we did for the third video. So if he only ran, that would mean he did 0 amount in walking. So we have 200R is equal to 1600. So how much time would he have to run? So 200R is equal to 1600, so we need to divide by 200 on both sides. That means he runs for, let's say 200 divide by 200. Let's make it really clear. That means he's running for 8 minutes. So he's not even going to go above 10 minutes of running. Like, that's awesome. An 8-minute mile? Yeah, that's totally doable for a middle schooler, 100%. If we have this next one, 200R plus 80W is equal to 1600. So what if he did not run at all? Maybe his knees hurt or something like that, or he just didn't feel like it for that day. So you guys feel like that sometimes, right? So if he didn't run at all, that means that whole part doesn't matter because we have 0 times 200, or that would just cancel out. So we have 80 times W is equal to 1600. That means we have to divide by 80 on both sides. Divide by 80 on both sides, and we get W is equal to 20 minutes. So these, running versus walking, those times that we would get, those are our intercepts. So again, we could easily graph those. And if we graph those, that line that we graphed would go through these other points that we already figured out here. Kind of cool. All right, hope that helped. Do not hesitate to message me or email me if you have any questions. And yeah, we'll go from there. Don't forget to do the must-do practice problems and try your hand at the exit pass tomorrow. Thanks for watching. Bye.